So hello everyone. Today we are going to solve our next question on LeetCode, that is jump game. So what this question is saying, you are given an integer array nums and each element of nums is representing that from there how many jumps we can take. For example, this 2 is representing that we can take at most 2 jumps from here. That means either we can take 1 jump or we can take 2 jump. Similarly, this 3 is representing that either we can take 1 jump, 2 jump or 3 jump, at most 3 jump. This 1 is saying that we can take only 1 jump from here and so on. Now let's try to understand it with the help of an example. And what we have to return, basically we have to return true or false. How we will evaluate this? If from the index, from the first index, if we can reach till the last index by taking these number of jumps as described in this array, then if we can reach till the last index, then only we will return true. Otherwise, we will return false. So let's try to understand this. Now, this is the example we are taking to solve this. Now, if you've seen this example, let's try to go till the last index from this 0 index. So we have to go till the last index. And if we can reach till the last index, that means we have to return true. Otherwise, we will return false. So this 2 is representing that from here we can take at most 2 jumps. That means either we can take 1 jump or we can take 2 jumps. And after taking these 2 jumps, we will reach here at this place. Now from this 3, if you will see, it is saying that either we can take 1 jump, 2 jump or 3 jump. This one is saying that we can take only 1 jump. This one is saying that we can only take 1 jump. This 0 is saying that we cannot take any jump. So try to make any number of combination. You cannot reach from this index to the last index. So here in this case, you will return false because you cannot reach till the last index. Now let's try to take a case where we can reach till the last index. So let's try to make this 3 as 4. Now we will again try. From this 2, we can either take 1 jump or we can take 2 jump. From this 4, uh, we can either take 1 jump, 2 jump, 3 jump and 4 jump. And after taking 4 jumps, we have reached at this index. From this one, we can take only 1 jump. From this one, we can take only 1 jump. And this 0 is saying that we cannot take any jump from here. But as from this first index, we have already reached till this index. So basically, we will see that this 4 is saying that from here, either we can take 1 jump, 2 jump, 3 jump, and 4 jump. And after taking 4 jump, we have already reached at this index, which is the last index. So in that case, we will simply return true. So now how we will solve this? So what we are going to do, initially we will take a variable max index and its value initially is equal to 0. Now what we will do, let me write the index first. Now if you will see that the value of the element, that is 2, plus the value of the index together is equal to 2, which is representing that by taking at most jump, by taking maximum number of jumps till which index you can reach. So from here, if you will take 1 jump, we will reach at this index 1, and if we will take 2 jump, we will reach at this index 2, and this 2 is equal to this 2. So this element plus this index together is representing that how at which maximum index you can reach from here. If you will see on this 3, then from this 3, if you will take this element 3 and the number of index, the index value, that is 1, which is equal to 4. So this 4 is signifying that from this place we can reach till maximum index 4. So if we will take 1 jump, we will reach till second index. If we will take 2 jump, we will reach at third index. And if we will take 3 jumps, that is the maximum number of jumps that can be taken from here, then we will reach at this index 4. And so this is what it is representing. So basically we will take the value of the element and the value of the index, and it will tell you that till which maximum index you can reach from here. So this is what we will do here. Now let's start traversing from this 0th index. And what we will do, we will simply combine the value of the element and the index, which is equal to 2. Now from here we can reach till the maximum index 2. Now this maximum index is initially 0, but now this 2 is greater than 0. So it is saying that till maximum index 2, now from here you can reach. So we will simply replace this 0 with this 2. After that we will simply increase this pointer. From here we can reach till maximum index 4. 3 plus 1 is equal to 4. So we can reach till maximum index 4. So we will, as this 2 is lesser than 4, so we will simply replace this 2 with 4. Again, we will increase the index. From this 1, we can reach till maximum index 1 plus 2, that is equal to 3. So we can reach till maximum index 3. But as we can see here that this maximum index is already greater than 3. So in that case, we do not have to do anything. We will simply increase the pointer. Again, we can see that 3 plus 1 is equal to 4. So from here, we can reach till maximum index 4. And as we have already reached till maximum index 4, so what we will do, we will simply increase the pointer. In that case, 4 plus 0 is equal to 4. And as we have already reached, increase the pointer. Now in that case, if we will see, this pointer reached at this index 5, but this maximum index is signifying that we can reach only till maximum index 4. But in that case, this pointer is reached to 5. So this condition is violated. In that case, what we will do? We will simply return false from here. Why? Because we cannot reach till this index 5, as this maximum index is representing till which maximum place you can reach. So this is 4, and as it reached at index 5, so we will simply return false from here. Now we will take another example where we can reach at this place, reach till the last index. So what we will do, we will simply replace this 3 with 4. Initially, we will take a variable max index, which is equal to 0. Now we will start from 0th index. From here, we can go till maximum index 2, the value of the element plus 0, the value of the index, which is equal to 2. As this 2 is greater than 0, we will simply replace this 0 with 2. Increase the pointer. Again, we will check. We can reach till maximum index 4 plus 1 is equal to 5. Greater than 2, we will replace this 2 with 5. Increase the pointer. From here, we can reach till maximum index 1 plus 2, that is equal to 3. But this 3 is smaller than 5. Simply increase this pointer. Again, we can reach till 1 plus 3, which is equal to 4. But this 4 is lesser than 5. Simply increase the index in that case. From here, we can reach till 0 plus 4, which is equal to 4, is lesser than 5. Simply increase the index. Now, in that case, if we will see, we can reach till index 5 plus 4. 5 plus 4, which is equal to 9. So from here, either we can take 1 step, 2 step, 3 step, and 4 step. And as we can see that by taking at most steps, that is the maximum number of steps, we have already reached to the last index. So basically, as this 9 is greater than 5, so we will simply replace this maximum index with 9. Now, if we will see that we have already found the way to reach till the last index. So what we will do in that case, we will at every point of time, we will check the condition that whether this maximum index is equal to the last index. If at any point of time, this maximum index is equal to the last index, from here, we will simply return true. We do not need to go further, because let's say if we will go further, now we will increase the pointer here. 6 plus 2 is equal to 8. So 8 is the place where we can reach maximum. But this 8 is smaller than 9. So no need to perform any operation. We will simply increase the pointer. 7 plus 1 is equal to 8. Lesser than 9. Just increase the pointer. 8 plus 0 is equal to 8, which is lesser than 9. Simply increase the pointer. So we have reached till the last index. So as we know that in that index 5, by doing 4 plus 5, which is equal to 9, here this is equal to the last index. So it is signifying that we have already reached the last index. So in question, we have to return true or false on the basis of whether we can reach till the last index or not. And as we have already reached till the last index, so no need to make further iterations. So these iterations from here to here are of no use. So basically, we do not need to make these iterations. At every point of time, we will check for this condition whether this maximum index is equal to the last index, and if we will get at any point of time that this maximum index is equal to the last index, from there itself we will return true. So this is the question. Now let's try to write pseudocode for this. Basically, we have to implement this function can jump. So let's take this function can jump, and it is taking parameter as this nums array. Then what we will do? Initially, we will take this maximum index which is equal to 0. Then we will start traversing from this 0th index. Let's start traversing from this 0th index I equal to 0, and we will go to last index. And we will check that if at any point of time this I is greater than the maximum index, then it is simply saying that this I is greater than the maximum index. It is simply representing that we have crossed the limit of the maximum index. So until that point, this pointer should not go. And as it has gone and beyond the limit of the maximum index, so what we will do in that case, we will simply return false from here. Else what we will do? Else in the case, what we will do? We will simply update this maximum index, and what we will put? We will do maximum index equal to math.max of maximum index, comma, the nums of I, that is the element, plus the index. So this is the maximum index we have. After that, we have to check a condition whether at any point of time, if we are getting this maximum index is equal to this last index. So from here itself, we will return true. And finally, when we will come out of this loop, simply we have to return true. So this is what the question, pseudocode for this. Now, if we will analyze the time complexity and the space complexity, then we can see that we are starting traversing from this 0th index, and we are going to the last index. So it is basically the linear time complexity, that is order of n. And the space complexity, as we are not taking any extra space, so the space complexity is O of 1. So now let's try to code this. So here what we will do, first we will take a variable maximum index, which is initially equal to 0. After that, uh, also extract the length of this array into a variable. After that, we will start traverse from starting, and we will go till end. And we will check whether at any point of time, if this I is greater than the maximum index, here itself we will return false. Else what we will do? We will simply replace the value of the maximum index, which is equal to the maximum of maximum index and uh, the element and the index together. After that, what we will do? We will simply come here and we will check whether at any point of time, if we are getting that this maximum index is equal to the length of the array, equal to the last index. In that case, we have to return true. And finally, when we will come out of this loop, we have to return true from here. So let's try to run this. And it is running fine. Let's try to submit this. And it is accepted. So that's all for today. Thank you.